The control chart was developed by a guy called Walter Shewhart about 90 years ago. It's still not that common when it should be one of the most dominant data charts that we have. So Shewhart worked for Bell Telecom. They were putting telephone equipment under the roads, and it was extremely expensive to dig it all up again if there were any defects. And he was trying to sort out between system noise, what we now call common cause variation, and special cause variation, real defects in the equipment that could be sorted out before the equipment was installed. Now, he determined it wasn't possible to do it statistically from the numbers, so he chose an economic route. So if there was a signal for a special cause, then it was worthwhile going to investigate because there was probably something there to find. So here's an example of the control chart that Shewhart came up with. It's simply the data plotted in respect to time, but we add control limits. These are the red lines on the charts. And as you can see, one of the points has dropped below the lower control limit. And this is a strong signal that something has changed in your system and it's worthwhile going to investigate it and learn what's actually happened. Shewhart was very concerned to avoid what he called false alarms, where people would go and find something, but actually it was just down to noise in the system, or what we call common cause variation. When Shewhart developed the control chart, he used just one rule, points outside the control limits, as a signal for special cause. And this has become known as Rule 1. Now, many statisticians have added additional rules in order to increase the sensitivity of the control chart. But there's a danger with this, because you also increase the number of false alarms. Shewhart was very interested in the economic worth of finding these special cause signals, and he didn't want to waste people's time going to look for what was actually just common cause variation or noise. Probably the most famous of these additional rules are the Western Electric zone tests. But you may come across many of these additional rules, but you've got to stop and think before you actually apply them. Now, if you were part of a quality improvement team and you were desperate to see even the smallest hint of an improvement, then you might want lots of sensitive rules. But as a member of the board performing a governance role, you really only want to react to strong signals. So I would recommend that you stick to Rule 1, points outside the limits. However, there are a couple of other rules that you may come across. I'm just going to mention them here. And the first of these is 2 out of 3 points near the limits. Now, this can be 2 points near one limit, or 1 point near the lower limit and 1 point near the upper limit. It doesn't matter. There's still a signal. But this is an intermediate strength signal. Okay? And the third one is a weak signal. And that's 8 or more points above or below the center line. And this is called a shift. Now, whereas a shift is relatively easy to spot on a control chart by eye, because you can count to 8 fairly easily, picking out 2 out of 3 points that are close to the limits, you say, well, what does close mean? It's the final third of the chart up to the control limits. And you often need some complicated statistical software in order to be able to pick this out. So if you stick to just Rule 1, points outside the limits, then it's easy to spot and you can be sure that that's a strong signal and therefore worth reacting to. Sending somebody to find out what's happened here, because this is definitely a signal. So I'm going to finish off with a short passage written by J.R.R. Tolkien, or somebody like that. I can't quite remember. Anyway, you may have heard a passage like this somewhere else. This one goes, 1 rule for special cause, Rule 1 to find them, many rules attract the fools, and in confusion binds them.